Hello and welcome guys. So today we are going to learn how to implement linear queues. So before we go on and try implementing linear queues, we need to understand the basic properties of queues. So let's do a quick review. So in general, queue have two ends, front of the queue and rear of the queue, and whenever an element is inserted into the queue, it is inserted from the rear end, and whenever an element has to be removed from the queue, it can it is removed from the front of the queue. So you can imagine yourself either standing in queue for something like going to the supermarket or buying a movie ticket, etc. So you must understand that whenever you go into the queue, you join the queue from the rear, and once you are done getting the services, you leave the queue from the front of the queue. So this principle is also called FIFO in data structures. So FIFO means first in first out. So whatever item gets inserted into the queue at first, that items will be the first one to get out of the queue. So here we can understand that items are inserted from the rear end and items are removed from the front end. Okay, so let's see how we can implement a queue. So before we implement the queue, we need to initialize the front at 0 and we need to initialize the rear at -1. So I've already told you guys before that whenever we insert an element into the queue, we insert it from the rear position. So when we insert an element into the queue, we increment the rear index, and before we insert the element, we have to check if the queue is full. So a queue will be full if its rear will be at max -1, where max is the maximum size of the queue. So I'll show you guys after a while how I came to this condition. So similarly, before you remove an element, you have to make sure that the queue is not empty. The queue will be empty if the rear is less than front. We can deduce this from initialization step also. You can see that the queue has no element right now, and the rear is at -1 and the front is at 0. Since rear is less than front, the queue is empty. So now let us see what happens if I insert an element. Suppose I inserted an element P. So I've already told you we insert an element at the rear end. So whenever we have to insert an element, we increment the rear. So right now the rear is pointing at -1, so I will increase the rear by 1. So -1 plus 1 will be equal to 0. So at my 0 index, I will insert my element P. So right now the front is also at 0 and the rear is also at 0. So after that, I want to insert another element. So insertion is always done from the rear. So before inserting, I should increase my rear index. So right now the rear index is at 0, so I will increase the rear index by 1. Now my rear index will be at 1, so I will insert another data into my rear index. Similarly, if I need to enter another element, I need to increment my rear index by 1, so it will be at 2. So I will insert, let's say, another element here. Again, let's say I go on inserting another element, so again my rear index increases by 1, another element comes here. Again my rear index increases by 1, another elements come here, and again my rear index increases by 1, another element comes here. So right now the rear index is at 5. The queue had 6 slots, and right now the rear index is at 5. So the maximum size of the queue was 6 and the rear index is at 6 minus 1, that is 5. That is, rear index is at max -1 condition, so the queue is full. So I cannot insert any further element. So before inserting any element, I need to make sure if my rear is at max -1 or not. If my rear is at max -1, then I cannot insert any element because the queue is full, and if my rear is not at max -1, then I can insert elements. Now let's try and delete the element from the queue. So if I were to remove the first element, so let's say that P went out of the queue, so right then my front would have to be incremented by 1, so my front would be at 1 index. Suppose this queue element also is deleted, then my front index will again increment. So I will do this, if I do this again, then my front index again will increment. So you can see why the front will increase while we are deleting the element. So again, let's say I deleted the element, now the front is at here. Again, let's say I deleted the element, so front and rear are at the same place and this element is deleted. So right now my front is at 5 and rear is also at 5. Let's say I deleted the element again. So while deleting, I'll increase the value of front. So but my value of front will go beyond this. That is, it was 5 right now, it would be 6. So rear is at 5, my front became 6, so rear less than front case still hold, and it signifies that the queue is empty. So our condition works. That will help us to check if the queue is empty or not. So we have to make sure that queue is not full before we are inserting, and we have to also make sure that queue is not empty before deleting. So that is what we are going to remember as we move on to the programming part. Now let us look at the programming part. So before we start programming, let us first open our terminal, and then let us navigate to our desktop. You can create the file anywhere you want to create it. You can either do this, you can either create the file from terminal, or if you want to create a file, you can just click on file, then you can click on new file, and then you can again click on file. You can you can save the file in some format. Let's say this is my new file I'm creating, and I'm going to implement linear queue. So I saved the file as lq.c. Now let's save the file like this. So now let's start. So first we want to include the header file, that is stdio.h. So after including the header file, let's define our true and false value as constant, because he does not have boolean data type built in. So I just define true to be 1 and false to be 0. Then I will define the maximum size of my queue. Let's say the maximum size is 10. After that, let us define the structure of the queue. So let's call it queue, all capital. Let's call it queue, and then let us define its values. So it is going to have a front, let's call it f. It is going to have a rear, let's call it r, and it is going to have some data item of max size where we are going to store the elements. So now let us create some functions that we are going to use in our queue. So the first function that we are going to use is a function called isFull. This function helps us know if the queue is full or not. So we are going to pass an pointer of the structure we defined earlier. I already told you before why we use pointers to pass arguments, because passing address is efficient than passing values. So I created a pointer. Now just few minutes before, I told you guys that a queue will be full if its rear is at max minus 1. So we just need to check the condition. So if the rear pointer of my queue is at max minus 1, then I have to return true, otherwise I can return false. So I wrote the condition like this: if the rear is at max minus 1, it's true, else it is false. So, or we can simplify this by using conditional operators in C language. So instead of doing this, I can just use this hybrid expression that will perform the same logic in a simple line. So if SR, that is rear, is at max minus 1, we return true, otherwise we return false. So this greatly simplifies the code. Then in the similar manner, let's create another function called isEmpty, which is also takes the same argument as before, a structure pointer called s, which belongs to the queue. And I told you guys before, a queue is empty if its rear value is less than its front value. So this is the condition we are checking, whether the rear value is less than the front value or not. So if the condition is true, it's going to be evaluated as true, otherwise it's going to be evaluated as false. So I hope you got it. After that, we move on to the next function, and it's called inQueue function. So it does not returns anything. It is going to take two items. The first one is a queue pointer, and another one is an element. So what we are doing, I told you guys before, first we are going to increment our rear by 1. So after incrementing the rear by 1, we will put the data item in the rear index of the queue, because elements are always inserted from the rear end. So this is how we implement our logic. So after that, we use the same logic to perform a dequeue operation. So for dequeue also, we pass the structure pointer just like before, and while doing dequeue, what we need to do is that first we need to store the front of the queue in some values. Let me call that values ret variable. So we will return the value at the front of the queue. After that, what we do is that we increment the front by the 1. So in the example I showed you guys few minutes earlier, I showed you guys why we should increment the front after removing an element, because after removing the first element, the second element is going to be at the front of the queue, and I'm going to return the dequeued value. And since I am returning something, I should also change my return type of the function. So similarly, we are going to have two other functions. The first function is called check front. It is going to accept a queue pointer. It is going to accept a queue pointer as a parameter, and then it is going to return the front index value. So I'm just going to return the data items which is located at the front index. Similarly, we need to also make a function called check rear. So I'm just going to modify this function. So instead of returning the front value, I'm going to return the rear value. Now let us try and code our main module. So our main module, it will be like this. So we are going to need some variables. So let me just define some temporary variables that I might use in the program. Then let us define the queue. So I'll use the struct queue keyword. So after that, I will define my queue, and I will initialize its front to 0 and rear to -1, like we saw before. After doing that, I will show to the user a menu driven approach, where based on their choice the program will branch differently. So I created a variable called choice, then I'll use a do loop here, then I will use a do loop here. Okay, so I'll use a do loop here. After that, I'll use a do loop here, and then I will print something on to the user. So I'll print options such as I'll print in options for in queuing, then I will print options for dequeuing, then I will print option for checking front, and then I will also print options for checking rear. Then I will have an option for exiting the program. So these are my menu items. After that, I am going to accept an input from the user. So I will just accept an input from the user. So I will store that value in a variable. I'll store that value in a variable called choice, and I will perform switch statement on the basis of that choice. So let's just perform a switch case. So I'm going to switch on the basis of my choice. So if the user presses 1, that is in queue, we need to enter the element into the queue. So before we in queue, we need to make sure if the queue is full or not. So I'll just call a function called isFull. I will pass it the address of my queue, and then if this returns true, then I will print something like queue is full. So this is what I'll do. After that, if the queue is not full, then I will ask the user for the element they want to insert. So ask for element like this, and then I will accept it in one of the temporary variables I defined before, and then I will call a function that I defined for enqueuing. I will pass it the address of my queue, and then I will pass it the element as the argument. Then I'll show something like percentage d was inserted. Also something like percentage d was inserted, and here I will write tmp1. Similarly, I am going to break the statement. So after writing the case for enqueue, let's move on to case for dequeue. Code along with me. So before dequeuing, we must check if the queue is empty. So I'll pass my address of my queue, and if this returns true, then I'm going to print queue is empty. I'm going to print queue is empty. And if my queue is not empty, then I can remove the element. So I'll simply write here percentage d was removed. I'll write a black backslash here, and then I will call the function. My function is dequue. My function is dequeue. Then I will pass it the argument, that is my address of the queue, just like it would accept. So we will break this again. So I forgot to use inverted comma here. Let me just add it. Then in case 3 we are checking front, and in case 4 we are checking rear. So in case 3 we will check front, but before checking front we will use the same condition. If the queue is empty, then we cannot check the front. So we will just copy and paste the same code of dequeue, and I'll just write something like is at front, and while calling the function, I'll call a function called check front. So this is how my case 3 would work. So in case of case 4, I need to do the same thing. So I'll just copy this case 3, and instead of printing from the front, I will print something from the rear, and then I will I'll write here percentage d is at rear. Similarly, in case 5, I'm exiting the program, so I will write here simple by message. Then after that I will break this case as well, and in case of default values, I will ask the user to enter either 1, 2, 3, 4 or 5 only. This is how we implement a queue. So after that we need to terminate our switch case statement. So my switch case terminates here. So after my switch case terminate, I need to write an while condition for my do loop. So while the choice the user enter is not equal to 5, because at 5 we have exit case, so we will do this until the choice is not equal to 5. At last we will print an empty line, and then we will return a 0. So this is how we implement a queue in. We have 5 cases. Case 1 is enqueue, case 2 is dequeue, case 3 is check front, case 4 is check rear, and case 5 is exit. Now let us look at the output. Okay, now let's look at if our program performs well or not. So I'm going to open a new terminal here. My code is saved at desktop, so I'll navigate to desktop. You can use any IDE of your choice. You can use CodeBlocks, you can use Turbo C. So here I will I have a file called lq.c which I created. You can see the file name here. So I'm going to use a GCC compiler. So I'll just write lq gcc lq.c -o lq. So I have an error here at line 64. So let me navigate here. Okay, I have done some mistake here. So I forgot to write an address here. So I'll write the address there. I will save the program. then I will again run the compiling again. So here I have no error now. So let's see if our program runs well or not. So let's run our program. So we are in queuing. I inserted 12. It shows that 12 is inserted. So let's check the front. So you can see that 12 is at front, and let's check rear. You can see that 12 is at rear. So when we only have one element, the same element is the front and same element is the rear. Now let's add another element. Let me add here 15. So 15 was also inserted. So again let's check the front. You can see that the front stays the same because queue is a FIFO structure. We still have the first element we inserted, that is 12 at the front. And let's check the rear. You can see that we have 15 at the rear. So this proves that the element is inserted from the rear, and while inserting element, the front stays the same. So I hope you got it. So this is how we implement queue using C language. If you like my videos, please like. If you have any feedbacks, let me know in the comment, and if you would like me to cover other aspects of data structures, let me know in the comment as well. Thank you guys.